Hey there, aspiring web developers. Today, we're diving into a crucial topic for building robust applications: integration testing for APIs. You've probably heard of unit tests, which check individual, isolated pieces of code. But what happens when those pieces need to talk to each other? That's where integration testing comes in. Think of your API as a central hub, interacting with databases, external services, and even other microservices. Integration tests ensure these connections work smoothly. They validate that different components of your system, when combined, function correctly as a unit. Without them, you might find that while each part works perfectly on its own, they fail spectacularly when put together. It's about verifying the interactions and the data flow between them. So while unit tests are essential, integration tests give you a higher level of confidence in your API's overall behavior. Let's explore why this is so vital for API development. When we talk about API integration testing, we're really looking at a few common scenarios. First up, and perhaps most common, is API to database integration. Your API often needs to read from, write to, or update data in a database. Integration tests here ensure that your API's database queries are correct, that data is stored and retrieved as expected, and that any ORM, object relational mapping, or database client you're using is configured properly. Next, we have API to external services. Modern applications rarely live in isolation. They integrate with payment gateways, social media APIs, email services, or other third-party platforms. These tests verify your API can correctly send requests to and handle responses from these external systems. Finally, especially in a microservices architecture, you'll encounter API to other microservices integration. Here, one of your services might depend on another internal API. Integration tests confirm that these internal API calls are working as intended, ensuring seamless communication across your distributed system. Understanding these distinct types helps you structure your testing strategy effectively. All right, so you understand what to test. Now let's talk about how to set up your environment for API integration tests. The first step is to choose your testing framework. Depending on your language and stack, you might use tools like Jest or Mocha for JavaScript, PyTest for Python, Go's built-in testing package, or others. Pick one that fits your team's needs and provides good assertion libraries. Crucially, you need to prepare a dedicated test environment. Never run integration tests against your production database or live external services unless absolutely necessary and with extreme caution. Ideally, you'll have a staging or testing environment that mirrors production but is isolated, allowing you to run destructive tests without fear. And finally, manage your test data. Integration tests often depend on specific data existing in your database or external systems. You'll need strategies to create, clean up, and reset this data between test runs to ensure consistency and prevent flaky tests. This might involve seeding your database or using specific API endpoints to set up preconditions. Getting this setup right is foundational for reliable testing. Once your environment is ready, it's time to write the tests themselves, and this is where the real work happens. First, you need to define clear assertions. An assertion is a statement that a condition is true. For API tests, you'll assert things like the HTTP status code, e.g. 200 OK, 404 not found, the structure and content of the response body, and even changes in your database or external systems. Be specific about what you expect. Next, don't just test the happy path. Cover edge cases. What happens with invalid input? What if a required field is missing? How does your API handle errors from an external service? Testing these scenarios helps you build a more resilient API. Finally, it's vital to understand mocks versus real interactions. Sometimes, for external services you don't control, or to isolate a specific part of your system, you might use a mock, a simulated version of that service. This is useful for speeding up tests or testing error conditions from third parties. However, for true integration, you'll want to test against the real thing as much as possible to ensure actual communication works. So, striking the right balance is key to comprehensive testing. To wrap things up, let's talk about some best practices and common pitfalls when it comes to API integration testing. A major best practice is to integrate your tests with CI/CD, continuous integration, continuous delivery. Your integration tests should run automatically as part of your build pipeline. This ensures that any breaking changes are caught early before they reach production. Also, strive for maintainable tests. Just like your application code, your test code needs to be readable, organized, and easy to update. Poorly written tests become a burden, not a benefit. A common pitfall is flaky tests, tests that sometimes pass and sometimes fail without any code changes. These erode confidence in your test suite. Debug and fix flaky tests immediately. They often point to race conditions, timing issues, or unmanaged test data. Finally, don't forget to monitor and alert. After deployment, continue to monitor your API's interactions with its dependencies in the real world. Set up alerts for integration failures. By following these guidelines, you'll build a robust, reliable API that stands the test of time. Happy testing!